Welcome to this session. In this session, we will try to understand how our ISP routes our traffic, what ISP owns, how the traffic flows inside ISP, what routers exist at each level, and how ISPs connect to Google, Netflix, etc. All these things we will understand in this session. So, let us start. So, what all are the ISPs we are having as of now in India? We have Reliance, we have ACT, we have Tata, right? Airtel. All these are the ISPs which we are having, which provide us the internet, right? So you can buy their subscription and they will provide the internet on monthly basis, 6 monthly basis, like that. Now, the thing is, we are accessing internet from our home. This is way we are accessing internet from our home. Correct. We have a router here. This is provided by our ISP, right? Or we have bought it. So the ISP's cable come till our home. Correct. Fiber cable. Okay. Now we are accessing google.com, for example. Then how this traffic flow, let's understand this. Okay, so I am using ACT as the ISP. Okay, so let us try to understand how ACT works in my case. So currently, what kind of services ACT provides? So ACT is a last mile, means it's a last user. It provides the internet. Last user, last mile ISP provider. Okay, it's a fiber to home. It brings fiber networks to your home and it operates in main Indian cities, right? It operates in cities. So it's a national ISP provider, you can say, but mostly tier 1 and tier 2 cities it operates. But understand that ACT is not an entire network. Okay, it's not entire network, it's a network within the network. Okay, means it's a network within the internet. So what basically ACT does inside is it takes the request, it aggregates a millions of user requests. Okay, it has a millions of user, it takes everybody's request, it aggregates it. Okay, it aggregates it. It will have some router here. It takes all requests, aggregates it at city level, for example. Then it will take it at national level. Okay, they will have a national level one router and hand it on the global internet backbone. Okay, this is how they works. Now when we are at home, right? So we use laptop, phone, Wi-Fi router, correct? And our router connects to fiber cable of ACT, right? So we have seen the router gives us a private IP. So let us again draw it. So we have a user who is accessing the internet, who has a router here, which is connected with cable, fiber cable. Okay. Now what happens is first level, level 1. Okay. In first level, what happens? The router provides a private IPv4 address. Correct? Private IPv4 address is provided. Okay. And as soon as the user access google.com, for example, whose IP address this router doesn't know, then router will take that request and send it to the higher router. Okay. So what it does, private IPv4 address it has given. Now it has got a request which it doesn't know where to route. Then it will use NAT, network address translation. Whatever IP you are having, that IP will be converted with the help of network address translation and send it to the another router. Here you will have IPv6 address also. Okay. So it has converted into the routable IP, you can say. So now comes level 2. Okay. Level 2 is from your network to ACT's network. So what happens is the ACT will have a neighborhood office where your fiber optic cable goes, right? So how they usually do is, if you are staying in apartment with multiple houses using ACT, then they will install one switch. Okay, the switch and everyone's fiber optic cable which is going to home will connect to that switch, and that switch final cable connects to the ACT office. Okay, so that reach ACT office, right? ACT office. There you will find ACT access router. ACT access router. Hundreds and thousands of requests comes to this router. Okay. What all the technology ACT uses is VLAN. It uses VLAN. It uses PPPoE slash IPoE. Okay. Then DHCP. It uses this technology. So VLAN for what purpose? We have an individual network, right? Every flat has its own network. So everybody is divided into small network and connected via switch, right? This is one network, this is one network, and this is connected via a switch. Correct. So all this is VLAN. So what VLAN does it? It makes the network isolated. So everybody is isolated. Okay. Now PPoE. PPoE is point to point protocol over Ethernet. It's a point to point protocol over Ethernet. Okay. So what it does is, as soon as you use ISP, right, you need to log in with username and password. So this is what is your PPoE. So every request identifies with username and password. It's like you provide the username and password and ISP will give one IP to you. So it is that way. So IPoE, which we have seen, right? So here we don't need username and password. It is usually used in mobile networks and all. Okay, but our home networks ISP provider uses PPoE. And DHCP we have seen, right? What is DHCP? DHCP is like assigning a IP address to our devices. So this is also used in this. Now, how all this fit together? Now, let's see how everything, whatever we have seen, how this all fit together. So it fit together like this. Customer device. This is a customer device. Okay. Customer device will come from VLAN, right? So VLAN isolated. Correct. Then it will go to PPoE or IPoE. Okay. This is for authentication purpose, right? Username and password you need to give. Then it will come DHCP. DHCP will give IPv4 address, right? Then you can connect to internet. This is how the flow looks like for the customer. Now, level 3, what happens? Level 3. Level 3, every city. For example, request came to the ACT office. That is called the access router. Now, there can be multiple access router in the ACT network. Can be at apartment level, can be at some layout level, can be at some town level, can be at city level. Okay. So these are a ACT core network. Okay, so every city, Bangalore, Hyderabad, okay, Chennai, these are all these places the ACT provides the internet. So at this city level, there will be a core router present. Okay. And this is where at this level it became a core ISP. Means all the reinforcement, all the policies, everything, all the rules, handling failure, routing citywide traffic, all these things will be done at city level. Okay, by ISP. Okay, there are multiple protocols used by ISP in doing that. Okay, few are OSPF, then MPLS, then QoS, and traffic engineering. These are the protocols which are used by ISP inside to route our request. So OSPF is actually finding the best path for our packets. Okay, so it is constantly monitoring all the hops in the ISP network, and in case anything failed, then finding alternative. So what is the shortest path it will take? So all this logic engulf in this OSPF. MPLS is multi-protocol label switch. So in this what happens is all the packets, right, some packets will be labeled directly, and those will be sent to the destination directly instead of sending in the middle hops, because there are multiple hops in the middle, right? If every packet keeps on going to every hop, it is a time consuming. So what ISP does internally is it identifies the packet and label it. If it knows the shortest path, it will directly label with the destination and it will reach there. That is MPLS. Now QoS is a quality of service. So what happens is when the network has a huge traffic, we need to decide which are the important traffic which should go, right? So that's how QoS will help. So it will route the important traffic first. Then traffic engineering is about finding out the best path, engineering your hops properly. So all these technologies used by ISP internally. Okay. So till now, how the flow looks like? Customer router, customer router to ACT access router. There can be multiple ACT access router, correct? ACC access router. This all coming in ACT internal network. Okay, internal network, ACT national network, backbone network. But still, we have not reached a Google.com. All our traffic is flowing within the ACT network. Now, how ACT national network will be formed? All these cities like Bangalore, Chennai, right? Those will be connected together. Like Hyderabad, Chennai, connected together. So this way, all cities are connected and form a ACT national network. Okay. So they have a routers here. These are called the core routers usually. Okay. They will have very high bandwidth because all traffic will come here, right? And still we are not reached to the destination, right? So from national network, right, from national network we will go to the ACT internet edge. This is the final stage where the packet leaves the ACT network. Okay, so what is this is ACT is a ISP, right? But it is not a big ISP. So it comes to the edge router. This edge router will be connected to the main fiber optics cable which are flowing through the sea. And these fiber optics cables are owned by Reliance, big players, right? Tata, all these players, some other companies. So it will select one of these whatever they favored, right? Whatever plan they have as per that. So they will select one of these and send our traffic, right? But here one protocol is getting used, that is BGP. This is the important protocol. So what this protocol says is border gateway protocol, because our packet is now leaving the border of India, right? So what this protocol says is whoever is hosting a network like Google, some big company hosts their own network like Google, Microsoft, Netflix. So what happens is they have a huge network. They will advertise their network saying that if your request coming for this IP, then route it to me because I host that network, right? So all this advertisement, you can say, right, that if you want to come to my house, come to this road. I am saying like this. So similar way, all those companies, whoever host a major networks, right, they will advertise themselves and they will advertise in this manner, border gateway protocol. So there is a standard defined to advertise. Okay, so you can say that there is a final table will be there where everybody will list whoever owns the network that send it here. Okay, Microsoft, if it is there, send it here. Then this protocol will be used. The ISP uses this protocol and figure it out where is the network and then send it via the fiber optic cable which is present and owned by the different companies. And this way it will figure it out, okay, it is mean for Google, then it will hit the Google network. Then Google will route internally to the IP, whatever is our destination. So that's how the global routing decision is made. Okay. But sometimes what happens is these are the very famous networks, right? Google, Microsoft. So what happens is ACT will be having a direct peering with these companies. And sometimes what happens is these companies like Netflix, right? They establish their server in this own ACT network so that the request doesn't has to flow along and it will be served from the ACT own region, right? ACT own network, so that we will experience the fast service. So that's how Netflix movies render very fast, right? Because Netflix hosts some of its server in ACT network. That's why you can see that it gives some offer. If you join ACT, some 1 month subscription of Netflix will be free, right? So this way. So few important companies network ACT already knows. So instead of routing all these circuits, instead of doing all these circuits, it can directly send it to these ones. And some of the companies even host servers. So those will be served directly. So that's how the network for ISP looks like. So what we have seen, now let us recap. User access the internet. Okay, that comes in VLAN. Then it goes to switch, correct? It goes to switch. Then it goes to regional office, ISP regional office. There we will have a access router. There will be multiple access router. There will be multiple core routers. Core routers is at town level, city level, right? There will be multiple core router. It will go. Then it will go as a citywide. Then national wide, nationwide core router. Okay. Then it will go to the edge router where it uses a BGP protocol to figure it out the final network. Correct. If it comes out to be a Google network, then it will go to Google network. Then Google internally, now the request will be routed inside the Google network. So Google will figure it out the data center where its server is hosted and request is coming for, and it will route it here, and similarly your request will be sent back. And at each hop there will be a translation of IP will happen, because every router has a IP, right, assigned. So we have seen whatever translation of IP happens in our network, right, Wi-Fi router, that source IP will be translated. So similar way at each hop your internet IP will be translated and it will be maintained. Okay, so that when you get a response, the reverse conversion will be happen and the response will be served to you. So even if it looks like a very big chain, but all these things happens within a fraction of milliseconds. It is so fast because everywhere the request, the information will be cached. Means ACT does that, so that if this router itself knows where Google resides, right, then it will directly send here. So that's how it works. So this is all about today's session. If you like this video and if you are understanding in detail, then do like, share and subscribe to my channel and tell your friend about my channel.